A woman is walking down the middle of a street. She's drunk and can't walk straight. Every second, she randomly takes a step 1 meter to the left or to the right. There are sidewalks on both sides, each 2 meters away. Will she ever reach a sidewalk, and how long will it take on average? Let's first ignore the sidewalks and focus on what's called a random walk. After 1 second, she could be either 1 meter left or 1 meter right, both equally likely. After 2 seconds, there are 3 possible positions, and not all are equally likely. The center position can be reached in 2 ways, the sides only in 1. It's not hard to count the number of ways to reach each position. Just look at the reachable positions from the previous second and add up the paths. This builds the famous Pascal's triangle. The probability she's in a certain position after t seconds is a ratio, the number of paths to that position divided by the total number of possible paths, which is 2 to the power of t. But sidewalks change things. Once she reaches 1, the walk ends, so we stop counting any paths that go past it. We can build a probability tree, keeping track, second by second, of the chances she hits a sidewalk. Notice the sidewalk is only reachable after 2, 4, 6, and so on seconds. And the probabilities go like 1 second, 1/4, 1/8. That's a geometric series. It adds up to 1, meaning the probability she eventually hits a sidewalk is 100%. What about the expected time? That's the sum of each possible time multiplied by its probability. With some neat math tricks, the series converges to 4. So, on average, she reaches the sidewalk in 4 seconds. More generally, if the sidewalks are n meters away, she'll always reach 1, and the expected time is n squared. That comes from something called the gambler's ruin problem, but that's a story for another video. There is a fun twist. What if we remove one sidewalk entirely and let her wander infinitely far in one direction? Now, the triangle of possible paths evolves differently. To hit the remaining sidewalk in exactly 2t seconds, the number of valid paths involves the Catalan numbers. The total probability she hits the sidewalk is still 100%, but the expected time becomes infinite, because the probability of hitting it at time t drops like 1 over the square root of t, too slowly to sum up. So yes, she'll definitely reach the sidewalk, but it could take forever, on average. And that's why streets are built with 2 sides.